Have you ever wondered how could Google predict the exact next word whenever you're typing something in the search box? Have you ever heard of those mysterious networks which can write new music? Have you ever wondered how could your mobile predict the exact next word whenever you're typing a text message? Those and much more are not going to be mysterious anymore once you understand the recurrent neural networks, which are going to be explained in this video.
Alright guys, in this tutorial we're going to be explaining the basic concept behind the RNNs or the recurrent neural network. Right. Now the basic idea behind the recurrent neural network is that we take the output of this RNN, okay, and make it an input to this same RNN at the evaluation of the next time step. Okay, so let's assume that this is our RNN over here, okay, all this one, and we take the output of the RNN and make it an input or one of the inputs to this same RNN whenever we come to evaluate this, okay, RNN at the next time step. So if we notice what I'm saying here, I'm saying time steps, right? So the recurrent neural networks works with data that are order related, like related with time. So let's have a look at this ball. Now let's assume that you are a goalkeeper or you have designed a robot that works as a goalkeeper. Now in order to be able to catch the ball, you're going to have to predict the future position and movement of the ball a little bit before it arrives to that position. So in order to do that, you cannot just do this by looking at this position of the ball over here. You're going to have to look at this position and this past position, okay, and this past position. And based on those past positions, you're going to be able to predict that the ball is going in this direction. So in this example, we have seen how the past data can help us predict the future position and movement of this ball. So back to our RNN over here. Let's assume that our RNN has inputs which represents the current position of the ball, and it also uses the past output of the network to evaluate the future position of the ball. But if I bring your attention to the fact that the past output of the network depended on the past position of the ball. So the past position of the ball is encoded in this past output of the network, which we are using right now, in addition to the current position of the ball to evaluate the future position of the ball. So this is a very brilliant way to encode the past position of the ball into the process of evaluating the future position of the ball. But wait a minute, the evaluation of this past output also depended on a previous output that is before it. And this previous output also depended on a previous output that's before it also. And so on and so forth until you go to infinity. So it's like right now the evaluation of the current output of the network depended on all the history, the previous history before that. Okay, so this is the power of the RNN. So whenever you go ahead and evaluate an RNN right now, you're taking into account hypothetically all the previous data and history of the previous steps of this, okay, network. So right now someone will object and a classical question will be asked, and it is the following: why don't we just create a neural network with multiple inputs and each input represents one time step, and we just train the network on those multiple time steps and get the output for that? Why do we have to go through the headache of creating and inventing a totally new type of neural networks for that? So let's say your suggestion is that, okay, we have, let's say, 8 inputs. Each input is related to one time step. Okay, now that is fantastic, except for the following. Now let's assume that we have trained this network and we just have, let's say, 3 steps or 4 steps or 7 steps. Now in this situation, we're not going to be able to evaluate the output of the network. We're gonna need the whole 8 steps. Okay, so in other words, what the RNN is so good for is that it can deal with any number of inputs. So if you have, regardless of what you have done while you are training it, so if you have 2 steps, it will work. If you have 3 steps, it will work, and so on and so forth. All right, so this is a very fundamental fact about the RNN. So let's assume that we have an NLP, a neural network to process your language, and you just have, let's say, 3 words, or you have 20 words. In all cases, it will be able to process the output, okay, which you actually want. You don't need a certain number of words to come out with your output. I also want to show you this. 1997 solved the problem of getting an RNN to remember things for a long time, like hundreds of time steps. When and why to use the RNNs? It is when order matters, and it also allows us to work with different number of steps. All right, guys, so I've promised you to give you a code walkthrough where we train an RNN model, okay, using TensorFlow Keras. So what do we have to import? What does the instruction, okay, look like? Okay, in our case over here, we import, TensorFlow, we import the models, layers, and activations, and we also import the different types of layers which we want to use. And LSTM, okay, it's one of the RNN types, okay, which we can use. And we also import, okay, NumPy as well. So now this is the data generation part, the training data generation part. A lot of processes need to happen in order to put the data on the right shape in order to, train the RNN, right? So I'm not going to go through them, but I'm going to show you the final shape of the data. Okay. Now this is one step. Okay. This is the second step. This is the third, okay, steps. So the steps I was explaining before. Now this is step 1, this is step 2, this is step 3, and so on and so forth. And in our case over here, we have a batch of steps, and then we start over from 0, okay, to the next batch and the next batch. Okay, so each batch has got 8 steps, but it's not shown fully over here. So what are we trying to do with this model? Okay, in order to understand this, what this model is trying to do is trying to sum, okay, 2 binary digits. Okay, now each step is the summation of 2 digits. Okay, so 1 plus 1 equals 1 with carry 1. Okay, and 1 plus 1 equals 0, okay, with carry 1. Okay, and 1 plus 1 equals 0, okay, with carry 1. So this is our, okay, result over here. So now this is step 1, this is step 2, this is step 3. So at each step we sum 2 digits. So this is a very beautiful example to explain the RNN, where the output, okay, which is the carry, right, the output of each step is an input to the next step. So this is a very nice example which explains how the output of one step actually becomes one of the inputs and affects the evaluation of the next step. So in our situation over here, okay, this is a digit from the upper number, and this is a digit from the lower number. Okay, and this is one step. Okay, and this is a digit from the upper number, lower number. Okay, and this is one step, and so on and so forth. So this example is a very nice one actually to understand. Now, this part over here is whenever you want to define a customized layer. So right now, I don't want to go through it because I will give you something that's a little bit simpler over here. So how do we define the model? Okay, so just like any other RNN model, model equals, okay, Keras sequential, and you define whatever name of the model you want. Okay, and then you will use this one. Forget about this one. I will explain it a little bit later, but over here, you will use this one. Okay, so this is one of the most famous, okay, and probably you have heard of it before, the LSTM, long short-term memory. Okay, so model add long short-term memory, and this is the number of units, okay, which will define the shape of the output. And this is the input shape, okay? This is the input shape. So put it whatever actually suits, okay, so maybe in our situation, we can make it like this, okay? Right, so put it whatever actually, okay, suits your training data over here. Okay, and then you need to compile the model and define the loss, the optimizer, and so on and so forth. And then forget about this one. And then you need to do the fitting. Here is where the training happens. This is the training X and Y, the batch size, the epochs, and boom, you train your model. You get something like this. So let's evaluate. Let us actually evaluate the model. In order to evaluate it, you need to create your input variable and plug it into the model, and those to kind of like fix the shape of the data. So let's have a look at the shape of the input into the model which we want to evaluate the output for. In our situation over here, we have this is how it is going to actually look like. Okay, okay, so 0 1, you can modify it whatever you want, and then you can actually do the evaluation okay process, and it will sum it, and it will give you the final answer over here. All right, so you don't need to look at this particular unless you want to understand this particular example. I just want you to see the big picture okay over here. All right, I know it's a little bit messy. Just look at the main instructions over here. So what did we do over here? If in case, okay, yeah, over here, this is in case you did not use the long short-term memory and you just want to use your own customized RNN. You don't want to use the one of the main models. You just want to do and create your own layer, okay, of a cell, okay. So this actually defines your own customized layer, right? And you define everything, the weights, okay, and the evaluation for that layer, right? And you actually, okay, give it a name, okay, like an ABC. So you have created your own customized layer, okay? And then you're gonna throw it into what we call an API module. So let's assume that we did not use this one, okay, while we define our model. Um, we use this one. Now this, okay, you do a model add. Now this one, layers RNN, okay. This is what we call the RNN API, okay, Keras RNN API. What you do over here is you plug your customized layers which you have created, and you plug it over here into this instruction, and the RNN API will do the job for you. You will actually turn it into an RNN network. So it will transform it into a feed-forward network, okay, or from a feed-forward network into an RNN network. If you are not interested in creating a customized layer, please skip this part of the video, right? Now, okay, just some more things, okay, to actually, just for the sake of documentation of this example, I just want to explain what does the instruction concat mean, because it's actually used in the code. In case if you have matrix A and matrix B and you concat them, that means to put them into a chain, right? So if you have 111 2 2 2, concat means, or concat means 111 2 2 2. So in order, because you need to concat the output from the previous, a step with the inputs from the current step, and you need to put them, okay, as one input to the okay, to the RNN, right? So this is what the concat means, right? That is all what I wanted to explain for you guys. Thank you so much for listening, and see you later.